Hello friends, welcome to Blackboard Tutorials. Today we are going to solve a system of linear equations by matrix method. Suppose we are given the system of these equations in two variables. Now this system can be written as Ax is equal to b, where this A is coefficient matrix and X is variable matrix since there are two variables, and B is constant matrix. Now we are going to solve this system of equations. So the solution of the system depends upon the determinant of coefficient matrix. So we will find the determinant. So determinant of A is equal to, just cross multiply these two elements, 2 into 2 that is 4 minus 3 into 5 that is 15. So this is equal to minus 11. So this is non-zero. So determinant is non-zero means our coefficient matrix is non-singular. So if it is a non-singular, then we are having unique solution. We already seen this. If this determinant is non-zero, that means matrix is non-singular and it has this has unique solution, and this unique solution is given by X is equal to A inverse into B. So this A is non-singular here. Okay, so that means it has unique solution. So this solution can be founded because A inverse exists since matrix is non-singular. So X is equal to, the solution is given by X is equal to A inverse of B. So here we need to find the inverse of coefficient matrix. So how to find inverse? A inverse is equal to 1 upon determinant of A into adjoint of A. Okay, so we are having a 2 by 2 matrix. So how to find adjoint of 2 by 2 matrix? We will find this as adjoint of A is equal to, first what we will do, since it is a 2 by 2 matrix, we will interchange the diagonal elements. So 2 2 are interchanged, so again we are having 2 2 after interchanging the diagonal elements. And what about non-diagonal elements? The sign of non-diagonal element changes. That means this will be minus 5 and this will be minus 3. So this is now adjoint of coefficient matrix. Now what will be the solution? Solution will be A inverse of B. So we need to find A inverse. So what is A inverse now? This is 1 upon, what was the determinant? It is minus 11. So it is minus 11 and adjoint is given to be 2. Okay, so what is adjoint? Adjoint is given to be 2 minus 5 minus 3 and 2. So this is now inverse. Okay, A inverse. So the solution is given by X is equal to A inverse of B. Okay, so we have to take product of A inverse and B. So A inverse is minus 1 by 11 and the matrix 2 minus 5 minus 3 2, and matrix B, that is constant matrix, is given to be 1 7. So this is equal to minus 1 by 11, and now the product is given to be A is 2 by 2 matrix, B is 2 by 1 matrix, so resultant matrix will be 2 by 1. So it is 2 into 1 plus minus 5 into 7, okay, and second row will be minus 3 into 1 plus 2 into 7. So this calculation will be minus 1 by 11. So this will be 2 minus 35, and this will be minus 3 plus 14. So after calculation you will get this as minus 1 by 11, and this will be minus 33 and 11. So now we are having minus 1 by 11 scalar. Multiply this scalar with the matrix. So this will give us 3 and minus 1. What is LHS here? LHS is x. X is equal to 3 minus 1. But x is the variable matrix, and which is nothing but xy. Now these two matrices are equal, that means corresponding elements are equal. So x is equal to 3 and y is equal to minus 1, and this is the unique solution of our system. X is equal to 3 and y is equal to minus 1. Now consider another system of equations where three variables are there. So write the system of equations in the matrix form, which can be written as Ax is equal to B, where A is the coefficient matrix, B is the variable matrix, and B is a constant matrix. So the solution of this system will depend upon the determinant of coefficient matrix. So we will find the determinant of coefficient matrix. So this determinant is equal to determinant, we will expand the determinant along first row. So this will be, first element will be 3, delete first row and first column, whatever determinant is remaining, find the determinant. So it is 2 minus 3. So 2 minus 3. Second element will be minus of minus 2. So delete first row and second column. So we left with 2 minus 1, 4 and 2. Take determinant of this. So this will be 2 into 2, 4. Okay, minus 4 into minus 1. So minus minus, that will be plus 4. And third element will be plus 3. This will be minus 6. Delete first row and third column and take determinant of remaining elements. So this will be minus 6 minus 4. So the determinant will be 3 into minus 1 plus 2 into 8 plus 3 into minus 10. So this will give us minus 3 plus 16 minus 30, which is equal to minus 17. So it is minus 17, that means it is non-zero, and non-zero means the coefficient matrix is non-singular. And if it is a non-singular, coefficient matrix is a non-singular, then the solution is unique solution, and that solution is given by x is equal to A inverse of B. Okay, so our coefficient matrix is non-singular, so we are having unique solution. So for that purpose we need to find A inverse. But before that, how to find A inverse? We have the formula A inverse is equal to 1 upon determinant of A, adjoint of A. Okay, so first of all we need to find adjoint. So adjoint means we have to take cofactor matrix, and then we have to take transpose of that cofactor matrix. So first we will find the cofactor matrix. Our matrix, I will write here, our matrix was 3 minus 2, 3, 2, 1, minus 1, 4, minus 3, and 2. So see, we have to find cofactors. So how will you find cofactors? The cofactors are given by A11. A11 is equal to minus 1 to the power 1 plus 1 M11, where M11 is the minor of first element. So this will give us, this is equal to minus 1. Similarly, A12, that means minus 1 to the power 1 plus 2 M12. M12 is the minor of this element. How will you find minor of this element? First, delete first row and second column and take determinant of remaining elements. So this will give us the cofactor as minus 8. Similarly, A13 will be minus 10. A21 will be minus 5. A22 will be minus 6. A23 will be 1. Okay. A31 will be minus 1. A32 will be 9 and A33 will be 7. So these are the cofactors. Okay, but we need to find adjoint of A. Adjoint of A is what? It is the transpose of cofactor matrix. First of all, we will write cofactors. It is minus 1, A11, A12 will be minus 8, A13 will be minus 10. Then A12 will be minus 5, A22 will be minus 6, A23 is 1, and A31 is minus 1, 9 and 7. Now take transpose of this cofactor matrix. The transpose of cofactor matrix will give us adjoint, and this adjoint is given by adjoint of A is equal to, what is transpose of the given matrix? First row will be now first column minus 1, minus 8, minus 10. Second row will be the second column, minus 5, minus 6, 1 and minus 1, 9, 7. So this is our adjoint of A. So now we can find the inverse. Inverse is given by 1 upon determinant of A into adjoint of A. So this is equal to 1 upon, what was the determinant? Determinant was minus 17. So this will be minus 17 and adjoint is this matrix minus 1, minus 8, minus 10, minus 5, minus 6, 1, minus 1, 9 and 7. Okay. So this is the A inverse. So now the solution is given by, what is the solution? Solution is given, and we already know that solution is unique, and that solution is given by x is equal to A inverse of B. Okay. So we have to multiply A inverse and B. So A inverse is given by, it is equal to minus 1 by 17. So minus 1, minus 5, minus 1, minus 8, minus 6, 9, minus 10, 1 and 7. This is A inverse. And B is our constant matrix. So that constant matrix was 8, 1 and 4. Now here we know that this is 3 by 3 matrix and this is 3 by 1 matrix. So number of columns is equal to number of rows, means matrix multiplication is possible, and the resultant matrix will be of order 3 by 1. So it is given by, it is equal to minus 1 by 17. So the resultant matrix will be of order 3 by 1, means 3 rows and 1 column. So it is given by minus 1, okay, minus 1 into 8 plus minus 5 into 1, minus 5 into 1 plus minus 1 into 4. Okay. Similarly, you can find this as minus 8 into 8 plus minus 6 into 1 plus 9 into 4. And third element will be minus 10 into 8 plus 1 into 1 plus 7 into 4. If you solve this, you will get minus 1 by 17. This will be minus 17, minus 34 and minus 51. So now multiply this minus 1 by 17 scalar to the matrix. You will get 1, 2 and 3. And what is our LHS? LHS is matrix X, and matrix X is what? X, Y and Z. So now these two matrices are equal. That means what is value of X? X is 1, Y is 2 and Z is 3. Okay, this is the unique solution.